Hello and welcome to the second Unity lesson. So in this lesson we're going to really be getting pretty deep into scripting and coding for our game. So yeah, let's just hop into it. So under the our sample scene that we created last lesson, go to if you've created along with us, then there's the game object here that has the example script on it. You can open that up, you can double click on here, or you can double click on this part here, which I'll do, and just wait for that to load into Visual Studio. Okay, now that that's loaded, in the last lesson where I left off, we have a debug statement under start, and then nothing under update. So to go ahead, we can just delete this, we don't really need it anymore. And the first thing we're gonna really dive into is the fact that we attached this to an object in the last lesson. So back in Unity, we have this on this little sprite here. And because we have it attached to a sprite, which means it can be accessed, we can basically have it move the sprite around. So the first thing we will do, so let's, for an example, change the position in the world that that sprite is on. So position is a transform value, which we kind of covered yesterday. So if we go to transform.position, then we can set that equal to a new value. Now, if you remember position, if we go back to in Unity, then under transform we have position. There's an X, a Y, and a Z. So what that is it's called a vector. So a vector can be a vector 2 or a vector 3. A vector 2 is basically the X and the Y value, and a vector 3 is all three. So since we're making a 2D game, we don't really have to worry about the Z value, so we will say that is a new vector 2. And then in parentheses, we basically have to say what the vector 2 is. So how about we change the X position? So we will say transform.position.x. We'll want to maybe every frame increase it by 5 pixels, sounds good. And then comma, for our Y position, we'll just keep that the same. So we'll just say transform.position.y. End it off with a semicolon to say that that's the end of the line. Save that. And now if we go back into Unity, let's see what happens. So first things first, to make sure it'll be a good demonstration, we're just going to make sure, because right now it's on static. And since it's on static, it won't move at all. So let's change that to kinematic, so it'll move from the script but not by gravity. And then this one right here we can kind of ignore, so let's just set that to static. Whoa, and there we can go. 5 is a big value, so it is just, we've lost it already. It's very, very fast. So maybe we can slow that down a bit. So maybe instead of increasing it by 5 every time, because that seems a bit fast, we'll say 0.5. Now, one thing you'll notice here is that, well, just to recap, is that we're basically taking the position of the object and changing it to a new value, and our coordinates will be whatever our last position was for X plus 0.5, and then we're going to keep the Y position the same. So as you'll see now, we have an error, and that's what the little red squigglies mean, just like in Google Docs or something like that. If something's misspelled, it'll have the red squigglies. So an error in Visual Studio basically means that it's not going to work. Something's not right here. And the reason is we have to put an F after 0.5. Now you're probably wondering, why? Why in the world would we have to do that? And the reasoning's a bit more complicated that we should really get into right now, but pretty much for any non-integer value that you have to put an F at the end. So if for an integer is basically, if you haven't learned that in math, it's really any number without a decimal. So even if it was like plus -5, that's fine, there's no decimal. But if it was -5.7, then there's a decimal in it. So then we have to add the F to basically say, yep, that's okay, it's not an integer, but that's fine. So instead of an integer, it's basically it's called what's called a float, which basically means pretty much any number, whereas an integer is just a whole number. But let's just go back to plus 0.5f, save that, and then let's check what happens in Unity. Hit play. And as you can see, it's moving relatively quickly, but it's still a lot slower. It's really hard to say what the units are, but it's 0.5 units every time. So this will seem like it seems like a lot. Luckily, there is a better method of doing that, which we'll get into in a bit. However, say we want to really edit that value, like plus 0.5, that still seems a bit much, but it kind of gets annoying to go in and edit every time. Well, that's where a variable comes in. So if you've taken algebra, you know that a variable is pretty much what you don't know in a problem. And that's similar to what it is in code, but it's a bit different. Like in algebra, where a variable in the end will usually equal a number, this in Unity, or in pretty much in coding in general, a variable will end up equaling a number. But what a variable really does is it stores something. So if we go to the very top up here, we can create a few lines just by hitting enter a few times. And let's create a variable. So there's different types of variables. So like I mentioned earlier, there's floats, which are pretty much any number, and then there's integers, which are really you just call them int. So let's create a float variable. So we can say it's any number, and float. And what should we call this variable? Well, I'd say since we're changing our x position, we'll just say, we'll call this the new x. Oh, that is a sx position. So, and then you put a semicolon to basically declare it. So you'll notice that the n is lowercase, but position. I am very, very bad at spelling. But you'll notice that the x and p are uppercase, even though the n is lowercase. And that's sort of a good habit to get into, is that you can start writing it, but everything that would be a new word, that you should have that as uppercase. And the reason is you can't have spaces in a variable. You do that, it has no idea what you're doing. So instead of spaces, every new word that programmers have in a variable, they'll pretty much capitalize. And that's just a good habit of getting into. Now, we could set a value to it. So say we want to set this to 0.1f, so 0.1. And then we want to change this, instead of plus 0.5f, we can say plus new x position. And that's why it was grayed out earlier. If we go back for a second, you'll notice that it turns a light gray because it's not being used. But then once we put in new x position here, it's like, okay, the variable's actually being used. And so instead of adding a direct number, it'll add whatever the variable equals, which in this case equals 0.1. So if we go back into Unity, as you can see, it's moving a lot slower now. It's still moving farther off the screen than we'd like, but for now that's fine. We can really just look at the process it's going through. Now, if we maybe want to make it a bit faster or a bit slower, and we could say, if we want to make it faster, we could say 0.05 here. However, that gets a little bit annoying, having to constantly switch through Unity and Visual Studio. So instead, we're going to do it in a bit of a better way. So we can still keep it saying as any value, but in front of float, you should put a left bracket and a right bracket and then a space. And then inside these brackets, with a capital S, write serialized field. And this, when I first learned this, I was like, what on earth is a serialized field? It did not make any sense, but it's best I just show you. So by saying serialized field before the value and then going into Unity, make sure you save that up. Then right here in our script, we have new x position. Now you can see that it has the spaces where they should be, considering we put in the capitalized x and p, and then it is set to 0.1. Now if we go back here, the new x position is at 0.05f, but here this is basically the master way of doing it. So anything we change here, we don't even need to change it in the code. So if we wanted, we could basically say that, yeah, the new x position, move it at 10, which is going to be wicked fast. See, it's gone immediately. Or we could be like, okay, let's move it at 0.005, which is going to be really, really slow. There it goes, very slowly. So you can really declare like equals this if you're having a serialized field. It doesn't really matter what you say it equals, because whatever it says in Unity will override it anyway, so you could delete that if you want. But by serializing the field, you're now enabling it to immediately be edited in Unity. So just like the position we can change, we can also change the scale of the transform. And that's very simple. We say transform.scale, or its local scale is the proper term, equals new vector2. We're going to do another set of 2 coordinates. And let's just say, a little Reddit notification, transform.position, not possession, we're not getting cursed here, .x, and let's increase this by 0.1f. We don't need to create a variable for this. It's just a demonstration, and we've already gone through that. And we'll say transform.y plus 0.2f. So change it up a bit. Okay. Oh, there's a little error here that I made. I said transform.y. If you might be screaming at your screen as to that's not right, it should be transform.local scale.y. And over here I also made a mistake. I said position, but that's not what we're changing here. We're changing the local scale. So right here we should say the local scale.x. Okay, save that and go into Unity, and let's just see what happens. Yep, so it's still moving a little bit, but you can see it's growing, and it's growing more vertically than it is horizontally, and that's because it's increasing by 0.2 vertically as opposed to just 0.1 horizontally. So we can stop that. I think that's a pretty good grasp on the transforms and how those work. But let's say we want to actually do something with these objects. So let's, for example, say that we want this one, and let's go back in the script. What if we moved it upward, and it moved up until it hit that, and then it stopped? Let's try that. So the scale we can keep the same, so we can just delete that. The position, we can get rid of new x position here. We will actually create a new float, so we'll do a new variable, so like before we'll serialize the field so we can edit it, a float, and we'll just say new y position. And now here we have, okay, we're going to do the x position, and then the y coordinate's going to be the y position plus our new y position. Excellent. So back over into Unity, we have our new y position here. It's currently at 0. Our new x position isn't being called anymore, so that one doesn't matter. Let's set this to 0.1. Let's make it relatively slow. And let's hit play and see what happens. Alright, so as you can see, it's moving up, and it just moved past that. And you might think, well, why is it doing that? Because in the last lesson, we can stop that real quick. In the last lesson, we gave them both colliders, so they should collide. This one's not a trigger, and this one's not a trigger. So why aren't they touching? Because everything seems right here. We have the y velocity, which we set to 0.2, and we're basically just setting, by doing this, we're setting our velocity to an upwards velocity of 0.2. So then we'll say if we want to make it a bit faster at 0.5, why in that case does it keep moving despite an object being right there? And you might remember from our last lesson, it's because colliding with another object is a force outside of its control, and this object is kinematic. So it's going to keep colliding with it. So what if we set it to dynamic? Well, then we get the issue of it's moving up, but there's a gravity pulling it down. So if we have the gravity scale, though, at 0, which we talked about yesterday, might not be useful in a regular sense, but in this instance, there it goes. You see, it's kind of shifting a little bit because of the collider on here is a bit wonky shaped with that little curved edge, but here it's done colliding. And in fact, if we want to get an even cleaner collision, then let's just remove this capsule collider and change it to a box collider like we had previously. Let's try to line this up kind of nicely, a bit nicer than it was originally. Let's hit play and see what happens. And now that we have a box and another box colliding, once they hit, there we go, it stays still, and they have touched each other. So because, and this one's static, but because the one that was moving was kinematic, it wasn't going to care, basically, about any other objects. But being a dynamic, then yes, it will matter. All we have to do is set the gravity to 0 if we want it to keep moving up. Or we could set the gravity scale to 2, or 21 by, I accidentally hit that, but let's try it at 2 for starters, and see what happens, because we have, so it's because we have 0.5 up and then a gravity scale of 2, so that it's multiplying the world's gravity by 2 as opposed to moving 0.5 up. So it's much, much stronger on the gravity. Whereas if we have a gravity scale of 0.01, which is a very, very small amount, and then a y velocity of 0.5, then even though there's gravity, it's going to move up because our y velocity is stronger than the gravity. But now that it's hit it, then we get into some weird stuff where, okay, it's going to move back down. That's interesting. So let's just set it to 0, make it simpler for all of us, honestly. So much less unnecessary math. And let's say maybe you want something to happen if they touch. So what we're going to have to do then is change well, we don't need to change them, but basically let's edit the layers. So basically we want, if this object touches this object, something will happen. So these are currently both layer default, and why we're doing this will make sense in a second. We could have it default, but let's create a layer. And here we have different layers that are bulletin layers, and then we have user layers where we can literally type anything in here. But let's not color layer anything. Let's call this layer, we will just call this block. I mean, that's a decent name for what this is. It's kind of just a big nothing, but let's just call it the block layer. So we'll call that block, and then back into this game object under layer, we can select block. So let's select this is a block and this is a block. So now, since we have this all set up, so when we hit play, it's going to slowly move up and touch that. Let's make it so something will happen. So in the code, this is going to be a new statement that we're actually going to have an update. Now, what we're going to say is that if this block touches the other block, then we'll just have, say, in the console, it'll type success. Now, if we said that at start, then that would mean right when the game started, if that happened, it would type it. But we don't want that, so let's do it in update, so it'll check every frame. So under update, we will say if, it says an if statement in parentheses, and then what do we want? We want if this block touches the other block. So we have to check. Right now, the way you can do this is basically saying if this collider here, this collider, touches an object, so if it touches pretty much any other collider of a certain layer, in this case block, then we want something to happen. So just like we said rigid body 2D, my rigid body, let's do a same thing. We have a box collider 2D, and we'll just call this my box collider. And then in start, right, we have my rigid body equals get component rigid body 2D. Let's say that my box collider equals get component, and then we'll say box collider 2D. Then end it off with the parentheses because we have to do that for silly reasons, and then just end that line. So if my box collider, and we have to say that if it's touching a block layer, dot is touching layers, this is how we do it, And the syntax here, basically the way it's typed, may seem a bit strange. Just roll with it, honestly. With certain things in Unity and with coding in general, some things may be like, well, that's odd how it's worded, but the more you do it, the more it'll become muscle memory. So it'll be is touching layers, layer mask, dot get mask, and then another set of parentheses. So make sure that a good way to do it is just to see if you go one after the parentheses, it'll say that this is the first parenthesis and this is the closing one. So in here, so that's set up fine. Then the mask will be called in quotes because it's a word, not an actual, it's not a variable, it's a word, as blocks. Was it block or block? That's a good question. It was block. I said it to UI. It was block singular. So if that is block, and as you can see, we have 3 parentheses at the end. This first one goes to this one. Second one is the actual is touching layers layer mask, and the third one's the if. So then if we do a left, the squiggly brackets, we just type a left one, a right one will appear, hit enter once, and they'll be underneath. So we're saying that if the box collider, if the object's collider touches a block layer, then this, whatever's in here will happen. And yes, it is a bit weird how you have to say is touching layers, layer mask, dot get mask block with like a million parentheses. But like I said, the more you do it, the more it'll just become second nature to you. When I first started that, I was like, what on earth does that mean? But the more you do it, the more I'll be like, oh yeah, is touching layers, layer mask, you have to get the mask. So then we will say, if you remember from the last lesson, to put something in console, you say debug, not decimal. Sometimes the autofill can be a blessing or a curse. Debug.log, and then in quotes, what do we want to say? We'll just say success. I believe I spelled that right. Alright, so then every frame it'll check to see if this happens, and if it does, then it'll say success. So nothing's happening yet. Oh, they're touching, and then every frame where they're touching, it'll say success now that they are. Excellent. So we're almost done with this lesson. I know it's a lot to take in with the code, so I encourage you after you're finished to just play around with what I've been teaching you. The more you do it, the more it'll become muscle memory, and the more that you'll start to really, really understand. Because I know personally, when I was taking courses, I got the concepts, but I still had to look back and I was like, wait, how does this work? How does this work? It's really, the more you do it, the more it'll just stick with you. So instead of saying every time an update, there is another way you can do it, and that's calling a function. And the best way, I think, is really to just show what I mean. So as you can see, these say void start and void update. And what a void does is it creates a function. So if we say void, we can just call this check touch, because we're checking if the collider is touching the other layer. Then last thing you do is just put parentheses to say that that's a function, and like the if statement, put the squiggly brackets and hit enter. So, bit of a rundown on what this is. Here we're saying void update, which is basically saying update every once per frame. Here we have void check touch. And the reason you might be like, well, why'd you capitalize the C on check? Because over here on variables, we didn't capitalize the first one. And is there a written rule that says you have to capitalize the first letter? No, there isn't. It's down to personal preference. However, what programmers, myself included, tend to like to do is that in a function, then we keep every first letter capitalized, whereas in a variable, the first letter is never capitalized. And that basically enables it so you can immediately look and go, oh, first letter's capitalized, it's a function. Oh, it's not, that's a variable. And then at the end of every function, you put parentheses. And that basically finishes it off. And now, just like the if with the squiggly brackets is if this happens, then this happens. Then basically, but squiggly brackets say what happens in this function. So really, we can just take everything here. So if this, then this. We can cut it with a Control X or Command X, and then paste that into check touch. And you might be like, okay, so why would we do that exactly? And the reason we can do that is that we can now say in update, all we have to say is check touch, parentheses. And you may be like, well, why don't we just keep it the way it was before? We would just say if in update. Why are we doing this? Say we have like 15 different functions that we have to be updating at the same time. It becomes a lot prettier and a lot neater to just say what we're doing and then just separate them all out, as opposed to having everything under update. And as you can see, now it'll basically act the exact same way, where it moves up, hits it, and then all the successes start flooding the screen. So right now, I hope that how that works makes sense, whereas we're basically saying check touch does this, and then we're calling check, it's basically saying, okay, do whatever check touch says in update. And this will become more important when we have multiple things happening at the same time. But yeah, that will conclude this lesson. Throughout the remainder of the course, you'll learn some more functions, but these are just some basic ones that I'd say are important to get down as sort of the basics of Unity. I don't know any of you have taken this course, if you have prior programming experience, you might have found it a bit easier if you did, but if you don't, and for this and the remainder of the course, that's perfectly fine. It'll all, even if it doesn't make sense completely right now, if you're thinking, okay, I think I get it, but the whole concept of programming isn't really natural to me, then the more you do it, it's really the more it'll come. I know I've been saying that a lot, but the more you do it, the more natural it'll feel in the end. So thanks for tuning in, and I hope to see you next time.